Just like we have load balancers in the on-premises, similarly we can have load balancers in cloud as well. So if I'm signing here. Okay, so basically, how do we have load balancers, right? See, there is a service in Azure called as load balancer.
So it's a service SaaS, right? Service as a software as a service, right?
Uh, Not software as a service, right? It's PaaS service you can think of.
Okay,
Software as a service is like mostly like applications we have.
okay. So, but this is a device sort of. Okay, platform as a
So,
service.
yeah. So we have a service called as Azure Load Balancer, right?
Mm-hmm.
Now this Azure Load Balancer, it works on layer number 4,
Okay,
right? It's a layer 4 service. So we can say it is working on layer 4, right? It is
mm-hmm.
basically working on the transport layer.
Yeah.
People also call this as NLB. People also refer this as network
Networking.
load balancer. It can basically distribute the network traffic, right?
Okay.
Now, this Azure load balancer is of two types. We can have an internal load balancer,
Mm-hmm.
or we may have a public load balancer, right?
Okay.
And it has got SKUs, means it can be a basic one,
Mm-hmm.
or it could be a standard one.
Mm-hmm.
So difference between basic is, see, this basic one would be free of cost, don't need to pay
Mm-hmm.
anything, but we will not get any defined SLAs, no SLAs.
Okay.
We can add up to 100 instances with this, and machines can be from single virtual machine skill set, and machines can only be a part of single availability set.
Okay.
In case of standard, we have to pay for it, so basically it's not free,
Mm-hmm.
but then there will be a defined SLA.
Mm-hmm.
We can add up to 1000 instances,
Mm-hmm.
so here, and machines can be, so machines can be from multiple availability sets. They can be a part of different availability sets, and they can be a part of multiple, say multiple VMSs, and can be a part of multiple availability set. So these are the differences. So basically we have four options. We can go with basic internal load balancer, or we can go with basic public load balancer, or we
Mm-hmm.
can standard internal load balancer. We can also go with standard public load balancer. So
Okay.
multiple options we have, right?
Mm-hmm.
So let's talk about the internal load balancer first. So let's say this is our network. Maybe in our network, let's say we have got two web servers. Let's say they are getting IP from the subnet.
Mm-hmm.
Now this could be our internal load balancer. This could be our laptop machines,
Mm-hmm.
and let's say maybe via internet we are trying to access it.
Okay.
So let's say this is our VNet one, maybe let's say 10.1.0.0/16, and let's say it's
Mm-hmm.
in the East US region. So this one will become subnet number 1/24. This one is going to be ws1 ws2, where let's say we are running the same application. So IP would be 0.4 and this one IP would be 0.5, right? So this internal load balancer will also have a private IP.
Okay.
Maybe let's say I'm allocating it 0.100. It's up to you. You can give it a dynamic IP. If we do dynamic assignment, it will get an IP 0.6.
Yeah.
If in case we want to do a static assignment, we can give it any IP of our choice. So
Hmm.
just like these machines are getting IP from the subnet, this internal load balancer is also getting IP from the subnet.
Okay.
These we are considering as our laptop machines. So this we are saying this is internet, right? So is it possible on these laptops via internet we can hit on the load balancer and then this load balancer can distribute traffic to these machines? Is it possible?
Internet. If
Yeah,
if they come to public IP, we have to make it like a we have to define policies on the load balancer, like where to send it.
right. So basically right now it's not possible because load balancer does not have any public IP.
Yeah.
So ideally it would not be able to accept any traffic directly from the internet.
Hmm.
But is it possible, let's say we have some client machines or we have different other member servers, maybe a part of same network, can they hit on the load balancer and
So
would they be,
it's the same subnet, though. So should be.
it could be same subnet, it could be another subnet. See in Azure we discussed as long as machines are getting IP from the same network, they
VLAN.
can talk,
Yeah.
right?
Yeah.
So
Same
they
VNet.
can,
Sorry. Yeah.
same
Same VNet.
bean, as long as they're getting IP from the same virtual network, they can talk.
Yeah.
So they can hit on the load balancer, right? So where they will
Mhm.
be hitting on the load balancer? They will be hitting on the front end of the load balancer. So we have something called as front end. So we're calling it as front end of load balancer, which is nothing but the IP of the load balancer, right?
Mhm.
And when traffic will be hitting on the front end, which is nothing but the IP of the load balancer, it will be hitting on a particular port. On a particular port, it will hit. And
Okay.
then as per the load balancing rules, load balancer will distribute this traffic to the backend pool of the load balancer. So
Mhm.
this is what we refer as backend pool, right? Where basically applications or database, whatever is running, where we are to distribute traffic. So
Mhm.
backend pool of load balancer, right? Okay. Now we have something called as health probe as well. So there's something called as health probe. See, what is health probe? Let's say load balancer is sending traffic to the machines in the backend,
Mhm.
right? But machines are not able to respond. Maybe they're off, some update is going on,
Mhm.
or maybe they are not healthy, they are unable to respond. So then we can do a health probe. And there are multiple ways by which we can do a health probe. So we can
Okay.
do a HTTP health probe, or we can do an HTTPS health probe, or we can do a TCP health probe, right?
Yeah.
So basically what happens in HTTP health probe, in HTTP health probe, load balancer will be sending a signal to the backend pool machines after every 15 seconds.
Mhm.
So after every 15 seconds, load balancer will be sending an HTTP signal to the backend pool machines.
Okay.
If the machines do not respond back within 31 seconds, and the signal should be HTTP 200 signal, right? So
Okay.
if the machines do not respond back within 31 seconds, and the signal has to be HTTP 200 signal, it means a failure has occurred, right?
Mhm.
It means a failure has occurred, right?
Yeah.
Okay. Now, if two consecutive failure will occur, right? If two
Mhm.
consecutive failure will occur, then this then this load balancer will basically remove the machine from the rotation. It will stop sending traffic to the backend pool machine, right? Now
Yeah.
this is customizable. We can customize this. So let's say if we want to send a signal after every 10 second, We want to send a signal after every 5 seconds, we can do this.
Yeah.
Or maybe after two consecutive failure, we want to stop, remove the machine from the rotation, or after three consecutive failure, or after four consecutive failure. So we can customize this, right?
Hmm. Yeah.
So basically, and see, let's say if in case it has removed the machine from the rotation, but still it will keep on sending the HTTP health probe signal, right? Let's say machine responds back after 1 hour, machine responds back after 2 hours. It will
Hmm.
again include the machine in the rotation.
Yeah.
So even after removing the machine from the rotation, it still keep on sending the signal to the backend to the machine, right?
Okay.
Let's say if we don't want to do this HTTP health probe, maybe we can do a TCP health probe, right? So
Yeah.
we can do a TCP health probe. So a TCP is basically a reliable connection. So in TCP, it try to do a three-way handshake,
Hmm.
right? In
Yeah.
TCP, try to do a three-way handshake. So maybe we can have a source, we can have a destination. All right. So this is how it may do it. So maybe here we can have a, let's say sending a TCP packet. See, source is nothing but the load balancer, and this is nothing but the backend pool machines. So let's say it is sending a TCP packet to the backend pool machine.
Yeah.
Backend pool machine says, hey, I have received the packet, I'm sending you an acknowledgement. And along with the acknowledgement, it will be sending its own TCP packet as well.
Yeah.
Now, if load balancer also responds back with the acknowledgement, it means everything is good, right?
Hmm.
If in case this handshake doesn't get completed, and again, if two consecutive or three consecutive failure will occur, the load balancer will remove the machine from the rotation, right?
Okay. Yeah.
So it's up to you. We have three options. We can configure any help row whatsoever we like.
Hmm.
Apart from this help row, we have something called as session persistence, which people also called as session stickiness, or people also refer this as session affinity, right?
Yeah.
So here also we have three options. So we have an option called as none, client IP, third is client IP and protocol, right? So none means, let's say here we have multiple machines. Traffic could be coming from any machine. So none means if traffic is coming from any machine, it can be sent out to any backend pool machine.
Yeah.
That's none. Client IP means, let's say for the very first time, traffic came from this machine 10.1.0.20, right? For the first time when traffic came from 10.1.0.20, it was sent out to 10.1.0.4. It was sent out to WS1.
Yeah.
So whenever traffic will be coming from the same IP address again in future, it will again be sent out to the same backend pool machine. That's the
Okay.
client IP. And client IP and protocol is if traffic is coming from the same IP following the same protocol, then it will be sent out to the same backend. That's client IP and protocol.
But what if the session is the new session?
For the first session, it can send it to any machine depending upon the traffic.
Yeah. Or depending on the load balancing method, right? And then if that session is terminated and the machine, same machine, start up a new session, then it might go to some other machine. But till that session is there, it will go to same machine, right?
Correct. Absolutely.
Okay.
Absolutely correct. Then we have something called as load balancing rules. See, what do we have in the load balancing rule? Where the traffic will hit. So we can see traffic will be hitting on the front end of load balancer.
Hmm.
When traffic will be hitting on the front end of the load balancer, it's nothing but the IP of the load balancer. It will be
Yeah.
hitting on a particular port.
Hmm.
Right? Then it will be distributing traffic to the backend pool of load balancer.
Hmm.
When sending traffic to the backend pool of the load balancer, again it will be hitting on a particular port on the load balancer. It could be a
Yeah.
destination port. Right? So that is something we can define in the load balancing rules. Now let's say we have one more network here. So let's say here we have, this is our VNet number 2, and maybe let's say here we have peering. between VNet 1 and VNet 2. So here
Hmm.
peering is enabled.
Okay.
Let's say here we have again two servers. Maybe these are also our same web servers where same
Hmm.
application is running. Let's say could be a different site altogether, web server 3, web server 4, where same application is running. So
Hmm.
is it possible whatever traffic is coming on this load balancer, it can distribute traffic to WS1, WS2, and can it also distribute traffic to WS3 and WS4? The answer is no, it cannot do this,
Yeah.
right?
So it has to be same VNet.
Yeah. So basically, backend pool can be from the same VNet. That's not possible.
Okay.
Is it possible? Let's say we have some client machines here. Maybe
Hmm.
some client machines are available here, and they want to access this application one. So is
Hmm.
it possible they can hit on the front end of the load balancer because we have peering in between, and then
Yes.
they would be able to access it? The answer
Yes.
is yes, they can do this, right?
Yeah.
This is possible. All right, let's see now. So let's say now we have something called as public load balancer,
Hmm.
right? Now this public load balancer, again, it is of two types. We have something called as regional public load balancer,
Hmm.
and we have something called as cross
Global.
regional, which we also called as global
Hmm.
public load balancer, right?
Hmm.
Okay. So let's say this is our network. This is one more network. Maybe in this network we have got two machines. Maybe they are getting IP from the subnet. Here we have a public load balancer. Maybe here we have some laptops. This is internet. That's to a naming convention. So I'm saying this is VNet 1, subnet 1. I'm saying this is WS1, WS2. Same application is running.
Hmm.
This is, let's say we are saying it is a regional public load balancer, which will
Hmm.
basically have a public IP, right?
Yeah.
So this is internet and this is our laptops. So is it possible that from laptops via internet we can hit on the regional public load balancer? We can do it
Yeah.
now because
Yeah.
this has a public
It's a
IP now.
public IP.
And now, as per the load balancing rules, this public load balancer can distribute traffic to the private
Yeah.
IPs of these machines, right? Let's say I'm saying here we have VNet number 2.
Hmm.
Here also, let's say we have some servers available. I'm saying that's WS3, WS4. So as we know, this regional public load balancer would not be able to distribute traffic to the other network, right?
Yeah.
It's not possible. So here also we will be needing a regional public load balancer, which will again have a public IP as well. And if in case, let's say we are running same application over here as well, if
Hmm.
in case we want to distribute traffic to these two networks, then maybe here we can have a global,
Yeah.
or you can say cross regional public load balancer, which will have a public IP. Okay? So basically, where traffic will be hitting? Traffic will be hitting on the public IP of this global or cross regional public load balancer. Then it will be distributing traffic to these machines, or sorry, to these regional public load balancers. And from
Yeah.
here, these regional public load balancers will be distributing traffic to these machines over here. That's how we
Hmm.
can distribute traffic, right? So here, rest everything is same. So again, we have front end of load balancer. We have backend pool of load balancer. We have health probe. We have
Yeah.
session persistence. and again we have the load balancing rules. Rest everything remains the same, right?
Mm-hmm.
Any question, any query before we do a
No,
quick
no,
lab into
that's
this?
good. It's almost same as other load balancers.
Right. So maybe, do you have an Azure account?
I have it, but it's on my other laptop. So,
Okay. Okay. So let's say this is our network, right?
mm-hmm.
Maybe what we want to do, let's say in this network, let's say we have one machine here, network subnet here, and here we have got two machines.
Mm-hmm.
And let's say here we have a public load balancer. So maybe from our laptops via internet, we will try to do. So I'm saying this is our laptops.
Mm-hmm.
So this is internet. I'm saying this is, let's say, public load balancer, maybe a regional public load balancer,
Mm-hmm.
which will have a public IP. This is VNet number one, let's say 10.1.0.0/16. It's in the East US region. This is, we can say, let's say subnet number one, WS1, WS2. So basically, in these machines, we will be deploying the web server role, right? It's the same application is
Mm-hmm.
running.
Yeah.
So here we want that when traffic will be coming via laptops, via internet, it should hit on here,
Mm-hmm.
and then from here it can distribute traffic to these machines.
Okay.
Now we would like to identify where traffic is going. So I'm saying whenever traffic hits on WS1, it should display this message:
Mm-hmm.
"Hello world from WS1."
Mm-hmm.
That we can identify the traffic is hitting.
Yeah.
And whenever traffic hits on WS2, maybe we should get this message, right? Now, what we would like to do, so maybe I'm saying for better security, no public IPs are assigned to WS1 and to WS2, and no public ports are open, right?
Yeah.
Now, if there is no public IP, there is no public ports open. How will we
Yeah.
make these machines as web server? So, to install the IIS role or the web server role, right? Server role, we will use Bastion host. If they don't have any public IP, how will we take the RDP? How will we deploy the IIS role? So maybe I'm saying here we will have the Bastion subnet. Here we can have the Bastion host. Using that, we would be able to achieve this.
Yeah.
So I'm saying this is Azure Bastion subnet 10.1.1.0 slash, let's say, 26. And this is Bastion host, which will have a public IP. Let's say we call it as Bastion public IP, right? Then we would also like to achieve this. So I'm saying for better redundancy,
Mm-hmm.
we will keep WS1 and WS2 in same availability set. Let's say AS1, right?
Mm-hmm.
For the better redundancy, we'll try to keep them in same availability set.
Mm-hmm.
Also, for better security, we will associate same network security group with
Mm-hmm. Yeah.
WS1 and WS2. Let's say we call it as network security group for the load balancer, right?
Mm-hmm. Yeah.
That is the name we are giving.